Intermolecular forces. Here, learners will have a chance to investigate the effects of intermolecular forces on evaporation, on surface tension, on solubility, boiling points, and capillarity. You need to be really organized with this, have everything set up for the learners and give them plenty of time to do it, because it is a prescribed formal assessment. Right, so what we're going to start off with is with evaporation. So they're going to be able to time how long it takes for the liquid to evaporate, and then be able to relate that to intermolecular forces. So we'll start off with a quick one, which is nail polish remover. And I'll get my stopwatch ready. And I've got a watch glass here because the nail polish remover would damage the plastic petri dish. I'm going to observe it. I'm just moving this watch glass a little bit so I can actually see it when it is evaporating. And then I can see it's actually just become a thin film on that watch glass. And before you know it, it's starting to cool down, just like a dam in a drought, towards just having a little bit left. I'm just going to put this lid back on while that's just busy evaporating. There, I got 1 minute, 13 seconds, and I'm going to write that in my table. Remember that paper is a much better way of remembering something than trying to remember it in your head. Okay, so nail polish remover, 1 minute and 13 seconds. Then what we're going to do is take some ethanol, and if they'd like, what they can do is have their stopwatch ready and get 4 learners, if they're working in teams, they can each drop as they start the stopwatch, and then as each one evaporates, they can mark down the time so they don't have to repeat it. If they try to do it where they do each one on one watch glass, then the next one, then the next one, that does work, but it's going to take a lot more time. One minute 16. Let's do my methylated spirits. And here, especially if you've got clear things you're working on, you can hold it up to the light to see the reflection, and then you'll actually see when it has evaporated. There, my methylated spirits has evaporated. It took 2.5 minutes, 2:29. And what I'm going to do with the water, I'm actually going to start it and then carry on, because water is going to take a lot longer to evaporate. Just while that's running, I'm going to carry on. I'm going to take a look at surface tension. So what I've got here is I've got 4 20 cent pieces. You could use 10 cent pieces, 50 cent pieces, depending on how much of the liquids you want to use. And we're going to see how many drops we can fit onto each coin. So let's start off with some water. I'm going to use the same pipettes that I used with the previous experiment, and I don't mix them up. I use the same one in the same container every time. So I'm just going to use a bit of water first, and let's see how many drops I can get onto a coin. Oh, got 35 drops onto a 20-cent piece before it spilt over. That was amazing. Right, let's try with the nail polish remover. I need to remember to write that down before I carry on. 35. And we're just going to give that a bit of space. It's actually quite difficult to even drop nail polish remover. It tends to drop by itself. Right. 1, 2, 3, 4. I got 11 drops on. So 11 drops of nail polish remover, which is mostly ethyl acetate. Now, let's try oil. Here we've got ordinary cooking oil, and you can see it's got that sort of, you can see it's definitely a much thicker fluid. Let's see how much of this we can get on. $25 drops. So I managed to get 25 drops of oil. And now we're going to try some glycerine. Here I can use my coin that had water on it. I managed to get 29 drops of glycerine onto that coin. Very thick, syrupy substance that. Try to use dry coins. If you have to reuse one of them, make sure you dry it off properly. The last one I'm going to do is with methylated spirits. So just on 15 drops, it actually started coming over the edges a little bit, although a lot of it was still sitting on the coin and it was just spilling over without drawing any off, just on 15 drops of methylated spirits. So there already I can see, for example, with the nail polish remover 11, methylated spirits 15, glycerine 29, oil 25, water 35 drops. So definitely came out tops there. Now remember, you don't want to give these figures to the learners, you want them to figure it out themselves. It's great for them to be observing, seeing what's going on, recording it, and then presenting it to you. So next we're going to look at solubility. So I'm just going to get my test tubes and we'll get set up for that. So now we're taking a look at solubility, and what we're going to do is just take the tip of a spatula of sodium chloride, of potassium permanganate, and if you have available iodine crystals. Just keep in mind with iodine crystals, that's very volatile, and if at all, even if it's closed, it'll probably stain everything in your kit brown. Then you're going to check that solubility in water. So I've got 2 mils of water in each of these test tubes. Afterwards, we're going to try that in ethanol. The curriculum also calls for with chloroform, but that's a very poisonous substance, so we're not going to use that, and I advise you not to give that out to your kids. So let's start off with the sodium chloride. I'm just going to take the tip there, and I'm going to drop that in, and we're going to check. What we can do is we can time that, check how long it takes, put and while that is going, and I'm looking at the properties of it, I can still see the little crystals. I'm going to take some potassium permanganate. So the learners would need to time this, and they'd also need to observe what happens. So what the learners are doing now is observing. They're timing how long it takes for the crystals to dissolve in the solute, in the water, and just observing what happens. And here I can see that the sodium chloride crystals, I can still see them. They're visible in the test tube. I'll hold it up to the light, but there's a lot less of them than we started off with. Now I know that those have now dissolved into the water. With the potassium permanganate, I can pick it up here, I can look at the test tube, hold it up to the light. There's a little bit of, hardly any, just a tiny bit of crystals at the bottom, and it is mostly dissolved. Beautiful purple color. Right, now next the learners are going to look at dissolving these in ethanol. So we'll just move those to the side. And you'll take 2 fresh test tubes, and you're going to need 2 mils of ethanol in each test tube. And then once again, just using the tip of a spatula, we're going to see how those dissolve. Again, I've got my drop of water timing over there, and it hasn't yet dissolved after at least 40 minutes. So they'd need to time this. They're going to use another timer. You could use a phone as a timer, and time how long it takes to dissolve. Remember, this is something the learners need to do, and you can move around while they're doing it and observe. So now the learners, they put it in, they take a look. I can immediately notice something different with the sodium chloride and ethanol. And now we're going to take the potassium permanganate. They'll time this as well. There we go. I'm already noticing something quite different here. And what I'm observing here, just for your sake, is that in the ethanol the crystals are not dissolving. Maybe over time we'll give them a bit of time to dissolve, but initially as I throw them in, the ethanol is still clear and I can see the crystals well defined. Whereas with the water, as I threw the crystals in, immediately I could see them dissolving. The water became a little bit more murky. With the potassium permanganate, it became purple. And here I can see in the ethanol it's starting slowly to dissolve. See around the crystals a bit of purple color. They can time that off. It looks like it's going to take quite a while for it to dissolve, and write down their observations on that. Next I'm going to just take a look at capillary action, and then we'll take a look at boiling points. So for capillary action, you'll need, you can use 1 capillary tube, but for the sake of brevity, I'm just going to use a few of them set up over here. And what we're going to need for that is 2 mils of water, of oil, glycerine, methylated spirits, and nail polish remover. I'm going to put the tube in and then see how high the liquid moves up the tube. Just take those out. Right, so we're going to do 2 mils of water. Right, when you've given that a little bit of time for the tubes to sit in the liquid and to have a chance for the capillary action to take place, then bring that just to the edge of the table, and you want to get your eye level with the test tubes. Just going to bring this around for myself. And now I can take a look at that capillary action, and I can measure off the levels. And for example, the glycerine is not entering the tube, so the methylated spirits has definitely gone up the most out of these. The others are similar, apart from the glycerine, which has hardly come up. Actually, it hasn't come up at all, maybe a tiny bit. Right, I can write down my observations here on the capillary action, which one's risen the most, try and measure it off a bit. Measuring accurately will be tough, but if you bring the capillary tube to the front of the test tube, you can get an average of at least which ones have a greater capillary action than others. Then boiling points. Here with olive oil and glycerine, they've got very high boiling points. So we can't heat that up enough in the lab, just on a normal spirit burner. And if the learners are heating it to that kind of temperature, you do risk burns and things, going up to like 290 degrees Celsius with glycerine. So with water, ethanol, and nail polish remover, I'm just going to set up for that, and we're going to quickly take a look at boiling points. So now we're taking a look at the boiling points with intermolecular forces, and I want just to clear my workspace a bit because I'm working with a flame, and we're going to start off with some ethanol. So what I'll do is I'll measure off just 5 moles of ethanol into a test tube. That should be fine, but now I don't want to heat this directly on the flame. Ethanol is very flammable, and if I heat it directly on the flame, there's going to be a lot of heat directed at one point, and that direct heat is just not going to be safe. Plus the actual flame itself could set off the fumes. So what I'm going to do is I'm going to put a beaker of water over here, and then I'm going to get my ethanol in the water. And so using the heat from the water, I'm going to heat up this ethanol in the test tube. Now what I can do is just put the bulb end of the thermometer into the test tube, into that ethanol, not against the side, and I'm going to check that temperature when that starts to boil. You could preheat the water to a point, but I'd like to catch it as it starts boiling. So now I've got that nicely bubbling away at 82 degrees Celsius, consistently bubbling at 83. So we've reached our boiling point of ethanol, and I want to remove it now. Just remember, it's hot. Make sure the learners don't burn themselves when working with hot apparatus. Alright, so I'm going to put in 5 mils of nail polish remover. And that is mostly ethyl acetate. There we go. Drop that in that hot water. And remember, now I've got my test tube in there, got slightly angled away from my face. When I want to now see if the nail polish remover is boiling, I don't want to lean right over and look down the length of the test tube, because then I'm getting those fumes right in my face. I can come to the side and view it from the side. And there we have my nail polish remover. It's starting to boil at about 75, just over 75 degrees Celsius. So now that I've checked those, I can write them down. My water boils at about 100 degrees Celsius. I'll check that as well. The learners have to check, record every single time. And then afterwards, when they've got all their results on a page, then they can present that to you in bar graphs, tables, and in summaries. I hope they've enjoyed learning about the intermolecular forces, and remember to take your theory as you teach the theory to apply it to each of these chemicals and experiments.